My name is R Crosby Lyles, and this is News from the Can. So this is Ice Age by request. So I'm going to break this down for you real quick. This is Paul Joseph Watson's video about climate alarmism and stuff like that. Well, you know, when your whole neighborhood burns down, you know, you kind of like lean towards Paul Joseph Watson. By the way, he's in the, I guess maybe this is his brand. He's selling Summit supplements. He's in the supplement business now, so he's probably doing okay with that, huh? That's what YouTube is really for. It's for marketing. I mean, if you're not going to be marketing stuff, you know, if you're just going to basically be trying to tell the truth, do it. You know, good luck with that. But let's move on here. This right here. So this is a video I put up recently. Doesn't have very many views. The guy's name, the authority, the actual authority on climate change is this cat right here, Dan Britt. Orbits Ice Ages in the History of Climate. Dan Britt is the guy who analyzed the core samples that they took around ocean basins and things like that. And I don't know if they did any ice cores, if he did any ice cores, but where they get their information from is taking cores, mud cores from the basins of shallow oceans, which is where you find oil. So this is an oil, the oil companies way back in the 60s and 70s, they did this, they analyzed climate change because oil is produced in the basins of shallow oceans. So that's how you know, that's geologically how you're going to find out where the oil is. Like the Permian Basin in Texas, which is a rather large basin. So Dan Britt, working for the oil companies, actually I think he was getting his PhD. He had went back to school, I think this was in the 80s, late 70s, 80s, somewhere in there. And he breaks it down, and basically the narrative is all climate change dudes will tell you the through line is sea level rise. All the fucking droughts, all the heat waves, all the big blizzards that you have and all that shit going on at the same time is all in the noise. The through line is sea level rise. That's the through line. You have ice melt and sea level rise. Basically, what he will tell you is the Earth is in an ice age, has been in an ice age for the last 3 million years. Boom. The Milankovitch cycles basically trigger interglacial periods and glacial periods. We're currently in an interglacial period. We are at the end of an interglacial period. Now we're going to go over here to this right here, where you will see that. So here we go. This is temperature, right? This is temperature. This is over the last, and this guy here is Maverick Star Reloaded. His deal is climate change related to magnetic pole reversal and things like that, which I've done. That's how I got into this thing. I did a video about that subject. Well, it was one of the first videos I ever made. Magnetic field effects on ocean currents. You can just look down my list of videos. It's pretty early on. I might put a link in the description. I don't know. Anyway, and it's interesting. However, you know, the subject of this video, what I'm talking about now, because somebody left a message and basically said, why don't you do more stuff on Ice Age? Well, the Earth is in an ice age, has been in an ice age for the last 3 million years. This is the graph you want to look at. This is the last 15,000 years. So, and then you got the medieval warm period and all that kind of stuff, and you see this line right here, right? And there's a spike, this spike right here. So, if you look further back in the geologic record, which is pretty easy to find, you will notice that there are spikes that are even higher than that are way up here. Every glacial period is preceded by a period of advanced global warming. See how this, you know, talk about that hockey stick. See this hockey stick right here? On the left-hand side, this one spike, and then, of course, there's the younger, driest cooling period where it drops off out of nowhere. I mean, into the abyss, right? But there's this spike here. And this is what climate looks like. It's this sawtooth wave thing. You know, it gets real cold for a while, or it gets colder for a while and warmer for a while. And because plant life drives a lot of this. Okay, so this thing here, it's like a light switch. A light switch is actually an exponential function. You walk across the room, which is this slow thing, build up. You get to the light switch, you reach out to the light switch, and you start applying pressure on the light switch. And that's an exponential force. And as the force builds, and the light switch goes off. So there's a lot of shit going on. So an example of that is you look out on a pond, if anybody remembers hyacinths, and you look out on a pond, and the thing you see the day before the pond is completely covered with hyacinths, it's about half covered. About half of it's covered with hyacinths the day before. The next day it's entirely covered, right? So if you look back, maybe the day before that it was a quarter, you know what I'm saying? So that's an exponential function. An exponential function is like boom, all of a sudden, right? You ever notice about in springtime, it's like there's no leaves on the tree, there's no leaves on the tree, there's no leaves on the tree, and bam! You look at a tree and it's all green. You're like, damn, when did that happen? It happened almost like instantaneously. That's an exponential function. So you're walking along and everything's cool, everything's great, everything's fine, and all of a sudden everything sucks. What we're experiencing, though, is, I mean, look, we live on a planet that spins with a heat source. So it's on a rotisserie. This is a cyclical, this is a sinusoidal, heating and cooling. And it also, and it wobbles so that, part of the North and South poles are in total darkness for months at a time. I'm sorry, but that's going to get cold. It just is. So how hot or cold that sunless part of the earth is going to depend on how much greenhouse you have, how much greenhouse gas you have in there. And greenhouse gas basically affects where it is. So it's like a blanket. If you hold it out from you, then you've got air movement in between, and your photons are allowed to go. Also, if you hold it in close to you, then you're going to warm up more. So it's true. When clouds, my nephew was on deployment in Afghanistan, 3 deployments in Afghanistan. And on cold nights in Afghanistan, which are brutally cold up in the high country, they would be praying for clouds, high cirrus clouds to come over, because when they did that, it would warm up. So yeah, cirrus clouds do that. Basically, though, if you ask if you ask Richard Lindzen, who is, professor emeritus at MIT, another, notable source for this kind of stuff. He's an expert in atmospheric chemistry. He will tell you that greenhouse gas in the stratosphere causes global cooling. It's a matter of statistics, that the photons have more of an opportunity to go out into space than they do back to the land. There's a caveat there about that, and I'm not really sure what the thing is with the Hongmatanga. Remember the Hongmatanga volcano was shaped like a shotgun shell and blew a whole bunch of water vapor into the stratosphere. This guy right here, Squatch Watch, Appalachian Squatch Watch, did a great video. The link is in this video here, where he talks about Hongmatanga volcano, and that they were afraid. Now, the Hongmatanga volcano erupted, well over a year ago. And so what they said was, because of the amount of water vapor that it ejected into the mesosphere, that something about that might be a first volcano, or the first volcano in modern times that actually caused global warming instead of global cooling, because it's mostly water vapor. And I was like, I don't know about that. That doesn't sound right to me. But it might be. Could be in this particular case. So that could be a thing. I'd have to look at the mechanics. Basically, my understanding of the mechanics of that is that if you do, the caveat to the greenhouse gas in the stratosphere thing, or in the high atmosphere, is that the way the Earth cools itself is you have evaporation at the sea surface level. Evaporation is an endothermic process. and so that it gathers heat from the surface, evaporation does, and then convection carries that heat, or that's a bad way to say it, it carries that energy up to the surface where that energy is radiated out in the form of heat into space. Well, if you have a layer of greenhouse gas up there, and what it does is it traps that. It's like throwing a blanket over the condenser of your air conditioner. It drives up the heat of the whole system, which could cause that whole entire air column, to get taller. And so that has effects that are really, that's like difficult to calculate. It's not trivial. So that's where you run into these effects where things snap off suddenly, where you have temperatures that go from wild extremes, from very hot to suddenly very cold. And so that's the subject of my whole channel is, look, you're not just going to boil. It doesn't happen that way. It does the climate is this jagged thing, and that's what makes it so wicked, right? The whole thing is wicked. It's like a buzzsaw. So here's the thing. I've been searching for, I have a video in here somewhere about the methane off switch hypothesis, which is a hypothesis that I've had. I don't know if anybody else has had it. Somebody may very well have, previous to when I thought of it. But the methane off switch hypothesis is that, as we can see right here in this particular case, every glacial period has been preceded by a period of advanced global warming, which means you got that hockey stick that goes way, way up, and then you see right here, it turns, there's a sharp turnaround, it's like a knife blade. So that means there's something that happens that causes that global radiative forcing to shut down suddenly and turn around and go all the way back down. So I thought, well, maybe what it is, hypothesis, maybe what that is that you have a period of advanced global warming because perhaps you end up with a lot of CO2, which plants love, and they overgrow, and they die off, and they overgrow, and they die off, and so it has this, expanding sinusoidal effect, and then it gets to a point where you have global warming, where it melts enough permafrost to where you have maybe a clathrate bomb, as they call it. Guy McPherson talks about the clathrate bomb and all that stuff. Goes off, and then you get an ejection of large amounts of methane into the stratosphere, because methane is light. It's like, I believe it has a molecular weight of 16, so it's pretty light, but it's a gas. And so it goes right for the stratosphere. And when it does that, it turns into carbon dioxide and water vapor on its way up. So it leaves carbon dioxide and water vapor, and carbon dioxide is very soluble in water. So basically rain, like what we're having right now, and especially snow, when it gets real cold, the sublimation temperature of carbon dioxide is, I want to say, maybe negative 80 degrees Celsius, somewhere in there. It's not, it's not terribly warm. It's not terribly cold. It's 100 and something. I want to say it's negative 80 degrees Celsius, somewhere in there. And those temperatures are doable in the stratosphere. Those temperatures are doable, in a sunless winter environment, in a polar region. And so that's what, they check ice cores for the amount of CO2 that it has in it. So obviously, snow traps CO2. So that's where the whole light switch thing goes. It's like you have that advanced global warming. Boom, a bunch of methane goes up, and then you have a rapid. You get like an albedo covering around the planet from water vapor. That necessarily has an albedo effect, shades the planet. So that was a hypothesis that I had then, and now I'm thinking, well, it could be. Hongmatanga, on the other hand, seems to have warmed the planet. It's kind of looking that way. We're looking at, today's weather maps. Let's look at that sea surface temperature anomaly. So, you know, that's pretty sick looking. I always like to look at the actual sea surface temperature and note that, you know, those temperatures are 10 degrees Celsius, which is 50 degrees. You know, out here in the green, that is 68. You know, so sea surface temperature anomaly. We're going back into an El Nino. By the way, 2019 was a very warm year, an El Nino year. Then the 3 intervening years were La Nina, and so we had colder sea surface temperatures in here. So anyway, Hongmatanga was down here in this group of islands down in the South Pacific near Fiji, east of Australia. So, and that looks, you know, it looks pretty compelling. You know, at the actual temperature, and you see that, you know, there are some parts in here that are those degrees right there. It's like 40 degrees, that pink coloration. 5 degrees, just like 40 degrees, somewhere in there. So, you know, and that's, I mean, that's generally cold water up there. So who knows? You know, when you look at the 2 meter temperature anomaly, you know, it's a mixed bag. Typically, you know, it's kind of a mixed bag. Now, you know, there's your El Nino, this equatorial stretch here in the eastern Pacific off of Ecuador, right? So yeah, Hongmatanga could be having that effect. You know, I don't know. You know, it's always, you know, we don't know. You always hear scientists, and it's such a pisser. We don't know. Yeah, I don't know. We don't know. These are all hypotheses. So my hypothesis was that if you triggered a clathrate bomb, that basically what that would do is that would bring on an interglacial period, or a glacial period, excuse me. A glacial period. All right? There's another wrinkle to that. I'm thinking, well, maybe that's not it. Because it all has to do with where that blanket is. If the blanket is further out from you, then you're going to have some, you know, you're going to have air travel, but you're also going to have photons are going to be able to escape from your locale, from your locality. It just so happens that trees and organisms like human beings give off volatile organic compounds. Hydrocarbons. And hydrocarbons, volatile organic compounds, and they're talking about smog. They keep bringing up smog. So you've got alpha pinene, beta pinene, limonene, and pardon me if I mispronounce these because, you know, whatever. Hematerpene, isoprene. The rate of emission of isoprene is light dependent and ranges between 0.04 to 2.4 parts per billion per square centimeter per minute. Is that per liter? I don't know. You want to ask a scientist. For oak, and that's for oak. Side note, very early in the morning, like around Florida, around here, oak like lets go of oxygen. It just like lets it out early in the morning. So it's like you wake up early in the morning, you feel like really good, you know, because oak is giving off oxygen. Cottonwood and eucalyptus foliage. What about pine trees? Animals, microorganisms, plants, all plants give off volatile organic compounds. The annual contribution of forest hydrocarbon emissions to the air pollution problem on a global basis is reflected in the 175 million tons of reactive hydrocarbons from tree foliage sources compared to the 27 million tons from man's activities. In other words, there is a 6.2-fold greater emission level from natural sources than from man-made sources. Long time to get to that little tidbit, which is pretty frickin' important. So here's the thing. That does not mean that man-made contributions are insignificant. And I've said this repeatedly, and I'll keep saying it until somebody hears it. Acid rain is way, 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 way worse. Acid is what caused the Permian-Triassic meltdown of the planet. The acidification of the oceans. The ocean had a pH of lemon juice. Caused 97% of all life in the oceans to die out. And 30% of terrestrial life survived. So it killed off 70%. So, and that's bad. You know, mass extinction is bad. We don't like mass extinction. I don't like mass extinction. I'm not a proponent of mass extinction. Human beings are definitely killing the planet. But there's more going on here, right? So I want to know, what I've been busily thinking about is, what's up with this? Why is that sudden turnaround? What causes that? It may not be methane. One of the things might be, or it might be all of the above. The methane part might be part of this going along here, right? And then you get up to this part. There's another video that I made. Oh, methane off switch to global. That's the methane off switch to global warming hypothesis. Methane trigger. Oh, so here's this. I'll put a link in the description. I believe this is Stopping the Coming Ice Age by Larry Efron and Andy Caffrey. Larry Efron and Andy Caffrey. So I talk about grinding up stones, rocks, because they had a problem in the 80s with acid rain. So they were used to grinding up rock and crop dusting lakes and things like that to bring them back to life, because the lakes were dying out because of the acid rain. And also they were using it to grow very large vegetables. The ones on the left are grown with the crushed up rocks, blah, blah, blah. Anyway, there you go. You are here. Right? So there's a guy who came up with a theory. You are here, meaning that there's this whole big glacial period, and then there's this teeny little interglacial period, and you are here right before the precipice of the drop-off. We're in the a part of the Milankovitch cycles where the planet should be getting colder. And they say, well, it's not. Well, that's because of man-made climate change and all that stuff. And so what they're afraid of is that we're going to switch back from an ice age planet to a hothouse planet, in which case the oceans would basically flood the entirety of civilization, which has probably happened before. It's probably happened in intervening glacial and interglacial periods, right? But his theory is that there's a cycle of forest fires having to do with circulation of the cells, and what's depicted here is the circulation of the cells and forest fires. So you have old growth forest fires, and what happens is you get a bunch of fires that burn and put a bunch of smoke into the upper atmosphere and blot out the sun. And I've always wondered, I ask it repeatedly in my videos, okay, well, if the big fear about nuclear war is nuclear winter, then why don't all these big-ass firestorms in these Arctic, Siberian forest fires and things like that, why doesn't that trigger a glacial period? What's up with that? I mean, from the smoke. So that's the theory, is that all these fires burn because the forests basically consume all the nutrients out of the soil, and they just naturally die off. And when they die off, there's a lot of forest fires. So my hypothesis is, in addition to the methane off switch, maybe interglacial periods are as much a function of volatile organic compounds given off by plants, because trees, and here's another thing, plants are aerobic life forms. So they use photosynthesis to produce food. They draw in carbon dioxide and water, and they produce food. The way they release the energy from that food is they draw in oxygen, they respirate, and they release that CO2. So these giant plants, these giant trees that weigh thousands and thousands and thousands of pounds, not only release massive amounts of volatile organic compounds, they also release massive amounts of CO2 in the wintertime. Because what are they doing in the wintertime? They're living creatures. Yeah, okay, so the temperature, maybe they go into some form of hibernation, but you can imagine that, when the sun is not really out, the trees have to respirate to survive, to live. Okay. And they're also giving off, all of these different alkenes and alkanes and things like that, and other volatile organic compounds that trap heat and are heavy. Methane, they're called non-methane volatile organic compounds. And they're heavier because they have longer chains. As many as 6, 10, they're heavier. So they stick around. They stick around in closer to the earth. So that's the blanket. That blanket is closer to the earth. So when you have a bunch of forest fires, what that does is burns everything down to the ground. So you don't have all those plants giving off all that CO2 in the wintertime. Because as this guy will tell you, Dan Britt will tell you that glaciation is caused from cold summers. Because thinking about this, thinking about where are the gases, what is the source, what are the particulars? Because when you watch aerosols, greenhouse gases, reactive gases, here we go. You look at the surface level, carbon dioxide, it wasn't that bad to get to. So this is the surface level. The red is 1,000 parts per million. And what you see is that it goes up to 1,000 parts per million and it drops way down to 300 parts per million. That is from plant respiration and photosynthesis. Notice that it is August, damn near August, and the amount of CO2 in the atmosphere is much less, up and above the 40th parallel, up above the 40th parallel. And the Arctic Circle, because the trees are getting sunlight and they're absorbing it. So, on the other hand, greenhouse gases, reactive gas, well, let's see here. Aerosols, pretty high, up in Canada. That's also from fires and things like that. So, but fires only last so long. Once the fire's burned up, the aerosols get washed out of the air with rain and what have you. It disperses. But if you have a living forest there, the living forest produces an air brake. It's like hair sticking up off the earth. Large, giant hair sticking up off the air that block air movement and trap all of that volatile organic compound heat trapping stuff. So when the sun is up and it's able to penetrate that, it's actually warmer. It actually warms things up. So now it depends. It depends on, you really got to drill into the particulars there. Because you're also going to have CO2 that's going to waft up from permafrost melting, because it's not just methane, it's also carbon dioxide and water vapor and all that. Water vapor is the biggest heat trapping source. But what happens is when all those forest fires, when those forests burn, it takes them a while to grow back, because those trees are hundreds of feet tall, 100 feet tall, 50, more than 50. So when they go, and they're big, giant, volatile organic compound, CO2 producing things, living beings. I'm giving off volatile organic compounds right now. This is how dogs can tell whether you have cancer or whether you have COVID or whatever. A dog can tell what diseases you have. I don't know why they don't do that. There's some reason, some HIPAA invasive, thing, some reason why they don't train dogs to sniff out disease. They very well could. Or maybe it's just because, you make more money with a MRI machine or whatever they use. So anyway, when those forests burn, you lose your heat trapping capability. A lot of your heat trapping capability is gone. So that's the hypothesis. When forests burn, that heat trapping capability goes away. The temperature is allowed to drop, and then you end up with sun blocking ash Forest fire ash also basically takes carbon dioxide out of the air. It's there's a chemical reaction that happens there. But anyway, so when you have a lot of stuff in the stratosphere and the atmosphere that blocks the sun, while you also have gotten rid of the heat trapping capability of the forests above the 60th parallel, temperature is going to drop. And if enough of it happens, and you look at the geologic record, like these big lakes that are loaded with woolly mammoths. It's like, what were all these woolly mammoths doing in this lake? They were running from a meteorite that hit the earth, or maybe a forest fire. Maybe they were trying to get away from a forest fire because they're all drowned in this lake. Hundreds of woolly mammoths dead in a lake because they were avoiding a forest fire. Forest fires apparently, as stated in this narrative here, that forest fires have something to do with it. So I'm looking for, in particular, what causes this turnaround. And is that in the crystal ball? Because if it is, it happens suddenly. And this is not just from these guys here. Where I stumbled into this is I read a book called The Coming Global Superstorm by Art Bell and Whitley Strieber, a couple of UFO guys, a couple of alien coast-to-coast guys. Oh, by the way, I should say that Whitley Strieber, I've read a lot of stuff that he's done. His story is fascinating. I referred to him earlier as, just basically an average guy, which he basically is. In terms of science, in terms of the science of climate change, he's not seen as these guys are not, Art Bell and Whitley Strieber are not seen as, rank and file scientists. They are, I respect them, and a lot of people do, but it just so happens that they nailed it, that they talked about things that, NCEP started looking for later on. So, and their whole thing is this right here, that there's a sudden change, that the glacial periods come on suddenly, like a thief in the night. And that's it. And we've already seen the shit's hitting the fan. Don't be scared. Be prepared. Means of communication, radio, shortwave radio, ham radio, citizens band radio. They make cheap versions, handheld versions that you can buy online. Bofang, people like that sell them. Water, medication for you and your pets, extra food, extra provision, blankets, ways to keep warm. If you live where it snows, make sure to keep an eye on the weather. 50 people died last winter, frozen to death in their cars, going to do whatever they were trying to do in Buffalo, New York. Got caught in a 500-year snowstorm, which is on tap. That's what's on tap. So yeah, you can absolutely die. Whatever you're using, make sure to have a stash of it somewhere. Make sure you don't have a reason to have to go out in the snow. Or either that or tough it out. It's better not to. Might be an opportunity if you get snowed. It might be an opportunity to detox, if that's your thing. It may not be your thing, but take that opportunity. Pick up the phone. Make some phone calls. Get off of that shit. Do yourself a favor. That's it. That's all I got. My name is R Crosby Lyles, and this is News from the Can. So you got the methane off switch hypothesis. Added to that, or maybe supplanting that, is the forest producing the fire squelching of forest produced volatile organic compound heat blanket reduction hypothesis, whatever you want to call it. That's it. My name is R Crosby Lyles. Thanks for watching. Love you guys. Take care. See you. Bye.